Okay, let's look at the homework 3.3, 3.4, number 10. Right? So we have a square sheet and we take off equal squares off all four corners and fold it up to make a open box, right? And we want to make it as big as possible, right? So let's do that. All right, so the volume can be written as V is equal to, right? The box is going to look like this. You have an open box. All right, then it has a square bottom, so it's 18 inch, so 18 minus 2x, right, times 18 minus 2x, right, and the height is going to be x, right? So 18 minus 2x is factor out 2, so it's a 2 times 9 minus x, and this guy is 2 times 9 minus x, right? So V is going to be, so 2 times 2 is 4. Then you have x here. Then you have a quantity 9 minus x squared, right? And x has to be between, right? 0 has to be the smallest, and all the way to let's see, probably 9, because it's 18 inches. You have to cut off the squares from both sides, so it's going to be 9, right? Then take the derivative to find critical numbers. So this is a function of x, so v of x. Derivative would be v prime of x, right? Remember that we're trying to maximize it, right? Derivative is going to be, let's see, 4 is just a constant multiple, put that there, right? Then use the product rule to take the derivative. Right, derivative of the first is 1 times the second is quantity 9 minus x squared plus first guy is x times derivative of the second is 2 times 9 minus x and subtract 1 from the power, 1, multiplied by derivative inside, which is negative 1. Right, and clean it up. So 4 was already there, 4. Right, you have 9 minus x here, and also 9 minus x. Actually, there are two of them, so pull that out. 9 minus x. All right, and what's left is going to be from the first term 9 minus x, so another one, 9 minus x. Right, then you're going to have a minus 2x, so you subtract 2x, right? So you can simplify 4 and quantity 9 minus x, right, times 9 minus 3x, right? So 9 and 3x has a 3 in common, so I'll pull out 3. So 3 times 4 is 12. Right? You still have quantity 9 minus x, but since 3 is factored out from 9, so it's 3. 3 is factored out from negative 3x, would be negative x. Right? We have that. Right? Set that equal to 0 to find the critical number. So critical number would be x equals 3 and x equals 9. Right? Right, so let's look at the volume at endpoint 0, volume at the critical number 3, and a volume at the other endpoint 9. Right? If you plug in 0 into the volume function, you can see that the volume is going to be 0, right? Because there's no height. And if you plug in 9, it's also 0, because 9 minus x is going to be 0, so it's 0. Right, then we plug in 3, so you can see that 4 times, right, x is 3, times 9 minus 3 is 6 squared. Right, so this is going to be 4 times 3 is 12, times 6 times 6 is 36. Right, what's that? 36 times 12, right? 2 times 6 is 12. 2 times 3 is 6, so 72. And 1 times 6 is 6. 1 times 3 is 3, right? So it's going to be 2 and 3 and 432, right? So this is going to be the maximum volume, right? Let's type it in. 432, right? Let's check the answer. All right, it came back, and looks like we got this correctly. All right, that's it. I hope that this was clear.